Dear friends, welcome to the next problem of belt drive, problem 10. The data of the problem is like this. Determine the maximum power that can be transmitted through a flat belt having the following data. Cross section of the belt is equal to 300 mm into 12 mm. Ratio of friction tensions is equal to 2.2. Maximum permissible tension in belt is equal to 2 Newton per millimeter square. Mass density of the belt material is equal to 0.0011 gram per millimeter cube. Friends, let us note down the given data in the problem. Here the cross-sectional area is given. So we can write width of the belt B is equal to 300 mm. Thickness of the belt is equal to 12 millimeter. Ratio of frictional tensions is given, that is tight side tension T1 divided by slack side tension T2 is equal to 2.2. Permissible tension in the belt material is given 2 Newton per millimeter square and mass density of the belt is given 0.0011 gram per millimeter cube. Here we need to determine the maximum power to be transmitted. We know that the maximum power transmitted by belt is given by P max is equal to difference of tensions, right side tension T1 minus slack side tension T2 into maximum velocity, that is V max. Let us say this is relation 1. The maximum tension that the belt carries while power transmission is given by T is equal to T1 plus Tc. Let us say this is relation 2 where maximum tension T is given by permissible tension in the belt per cross sectional area into cross sectional area of the belt. Substituting the values of it, permissible tension in the belt F is equal to 2 Newton per millimeter square. Width of the belt is 300 mm and thickness of the belt is 12 mm. So the maximum tension that belt carries T is equal to 7200 Newton. And in this relation, Tc is equal to centrifugal tension. We know that when maximum power is transmitted, the centrifugal tension Tc is equal to one third of the maximum tension, that is T by 3. Substituting the values, we found Tc is equal to 7200 by 3 is equal to 2400 Newton. Using relation 2, we can write T is equal to T1 plus Tc. So, rearranging the terms, T1 is equal to T minus Tc. Substituting the values of T and Tc, we found T1 is equal to 7200 minus 2400 and hence T1 is equal to 4800 Newton. Now it has been given that tension ratios T1 upon T2 is equal to 2.2. So rearranging the terms, T2 is equal to T1 upon 2.2. Substituting the value of T1 4800 by 2.2 will give us T2 is equal to 2182 Newton. And when maximum power transmitted, the maximum velocity Vmax is given by under root of maximum tension T divided by 3 times m, where m is mass of the belt per unit length, and we can calculate it by from density. So we can rearrange the term m is equal to mass of belt per unit volume into cross sectional area. That will give us this term mass of belt per unit length. So this mass of belt per unit volume is nothing but the mass density. So m is equal to mass density into cross sectional area, that is b width into t thickness. So on substituting the values, mass density is given 0.0011 into b is 300 to t is 12 mm. So we found it is equal to 3.96 gram per millimeter. Converting into kilogram per meter, so it becomes 3.96 into 10 raised to minus 3 kg divided by 10 raised to minus 3 meter. It gives us m is equal to 3.96 kilogram per meter. So maximum velocity Vmax is equal to under root of T upon 3m. Substituting the values is equal to under root 7200 upon 3 into 3.96. On calculation, we found Vmax is equal to 24.62 meter per second. Using the relation 1, that maximum power transmitted Pmax is equal to T1 minus T2 into Vmax. Substituting the values, we found Pmax is equal to 4800 minus 2182 into 24.62. On calculation, we found Pmax is equal to 64,455 watt. Rewriting it equal to 64.455 kilowatt. So the maximum power that can be transmitted through given belt drive is 64.455 kilowatt. Thank you, friends.